About agora voting system for a liquid democracy. Agora voting system, well, it comes from Partido Internet, a political. Okay, the main idea of this political party is that the member of the parliament, elected for this party, will vote. The people vote over the internet. They work as proxy representatives, and for doing this, you don't need to change any law. Also, the idea is behind this is liquid democracy, which is just like direct democracy, but with delegation, because you don't have time to vote everything that happens in the parliament. So, the Partido Internet created this software, Agora Ciudadana, which of course has some requirements. First one is security. Of course, the voting system needs to be secure. But what does it mean? It means that the vote must be secret. That's the first thing. You need to be sure that your vote, will be correctly captured. And also, another of the requirements is that we need to support massive elections. There are 46 million of people in Spain. And also, massive elections mean two things. That there are also not many people, but a lot of votings a year, 7,000 in the Congress. So the voting system needs to be to support this kind of thing. And of course, the third thing that needs to be supported as a requirement is vote delegation. So how the voting system that we are creating, how does it work? Well, this is the voting process. First, we have the trustees, which are the people or the entities we trust the secrecy of our vote. These entities could be the United Nations, Greenpeace, or political parties. So they should they should be of all kinds of organizations and people. So because the system guarantees that only if all of them collaborate and are corrupt, then your vote won't be secret. So as it needs to be difficult to this collaboration for corrupting the voting to happen. And then for voting, we need to generate a joint key. Each of these trustees generate a public and a private key. And afterwards, they publish each one. They publish in the public key in the bulletin board. We're using Helios voting system for this. Helios is made by Benedida and his colleagues in Harvard. He's a cryptographer. And then we have the delegates. As this voting system supports delegation of the vote, these delegates need to publish. Well, the delegates could be anyone, could be you, could be a political party, or any person, or dyslexic, or even an organization. And their vote must be made public before the election begins, so you know where you're going to vote if you delegate in these people. And then the voting starts, and you can either delegate your vote, or you can directly vote. Your ballot, when you vote over the internet, or your ballot will be encrypted by using El Gamal, which is a standard way of encrypting a vote or whatever. And then it will be signed. We used national electronic identification cards in Spain, which use standard protocols, and they are working. It's secure. And it will be signed with your signature, so the vote, which is encrypted so that no one will know what you really vote, will be signed, and everyone will know that that's your vote and not everyone else. And finally, when you send your ballot that you create in your computer, even without internet, in a computer with a live CD, if you want, you send it over internet, it's authenticated using your signature and cast by the server. Of course, published in the bulletin board so for everyone to see. Then the voting ends and the tally begins. The trustees now start to work again, and the way it works, the voting system, is that each trustee shuffles the votes and re-encrypt the ballots so that the ballots are anonymized. No one will know that this ballot was this other ballot because it's been re-encrypted and shuffled. This is what we call a mixnet. Each of the trustees do this process, collaborating, and in the end, when we have a list of ballots which are shuffled and re-encrypted, no one will know which is which. Then we can decrypt the ballots. This is also a work that is done by the trustees, doing a decryption distributed and of the anonymized votes. And of course, the results must be published in the bulletin board. But you get the proofs of decryption, proof of the shuffle that was correctly done, and the re-encryption, of course. So you can guarantee, even if the voting is corrupt, you know that this process worked or not, because the mathematics behind this guarantee it. Verificatum is the system that we use for all these mathematically complex processes, and this is done by people from cryptographers. This software is done by cryptographers from Switzerland, and these proofs I have mentioned earlier provide, as I said, universal verifiability. So even if the voting is corrupt, you will know it. Maybe your vote will be known. It will be secret because all the trustees are corrupt. But you will know that the voting is corrupt. This is serious stuff. We have a paper pending because there are a lot of secure voting systems. People don't know this, but it's true. There are a lot of secure voting systems, but they don't provide the delegation. And we are creating in this project a paper that we are going to present as soon as possible for that provides this delegation. And of course, this kind of thing is funding, but we're onto that. We are trying to create a foundation for liquid democracy. Of course, this voting system, when it's finished, which we are working on, can be used anywhere. It can be used in universities and colleges, even in companies to vote whatever you want, actually. And Elios voting system from Harvard that we are going to use together with Verificatum has been used already in universities for voting directors in France, and I don't know what other places. The status of the project, well, we've been working in the delegation method, which is really the most difficult thing since the 2009. And now we have a clear path. We want to use Elios and Verificatum, which is the fastest software for processing the votes. And we're doing just that, and also integrating the authentication in Elios for the DNA. So, well, if you are interested or want to join us, this is our web page, and you can contact me via my email. So if there are any questions or...
You said shuffling is encrypted and decrypting part is made by the trustees. Who is providing that solution to do that? Is your solution is a web page? You give them to do the work and you just trust them to change the sources, or how is it working?
How is it working? The
trustees part.
the trust.
That's the solution, or do they have to do this work by themselves?
The trustees, well, the question is how, I don't know if I understood correctly, how the trust works, actually. How...
No, the like Greenpeace part, UN, if this like groups are taking care of the shuffling, the encrypted and everything, are you providing them the
Of course, we provide the software. They can create their own if they want, because there is a protocol. But we have to provide them a software to do the shuffle and the re-encryption and the decryption. And they can use it, or they can create their own software if they don't trust it or whatever. And that's it. Yeah.
You said that in order for the trustees to shuffle, they have to re-encrypt them. So they have to decrypt the votes first?
No, the voting, the question is that I said that the trustees have to re-encrypt the votes and shuffle them. And the question is, does this re-encryption need to decrypt the vote to re-encrypt it? And the answer is no. The El Gamal encryption permits to re-encrypt a vote or anything, a text, without having to decrypt it. So you know that the two texts, the ciphertext, contain the same thing inside, but you don't know what it is.
So it will be double encrypted?
No, actually no. You just decrypt the last one once, and it is decrypted. It's a property of this encryption process. Another question?
Yeah. You said the work is still in progress. So when the first version will be available?
The question is, when will this be available? Well, we don't know yet. We hope that as soon as possible. We are working there. Developers, we have about 3 developers at the moment. The most difficult part was the mathematics behind this. And now we just need to take these projects, Helios voting and verification and authentication with DNA, and bring them together. And we're working on that, and we hope that at the end of this year we have something. We hope that. Another question?
Did I understand correctly that on the bulletin board you publish who has voted and who hasn't, so everybody can check who has voted and who hasn't?
The question is that does the bulletin board contain who has voted and who hasn't? And the answer is yes. You publish your vote, you sign your vote, so everyone will know that you vote. They don't know what you vote. Even you might vote abstention, or it might be the vote might contain a delegation. But yes. Any more questions? Okay.
Important part of voting is that the process can be checked again to see if people supposed to do the counting actually did the right thing. They actually didn't cheat. How does the system provide this?
The question is how can we? Well, he said that normally you want to know if the voting was done correctly or not. How do we do that? Well, as I said, we provide, the trustees provide proofs of what they've done. So you can check with these proofs that the process they did, which of course you cannot repeat because you are not the trustee, you don't have the private key that they do, but you can check mathematically that they did it correctly. And it's a proof, a mathematical proof. And actually, the current voting system in most countries, they don't provide any kind of proof. You just need to trust that the process was right, but there is no mathematical proof of anything. Any more questions? Where?
Be more secure to automate the encryption and decryption process. Because at the moment you're relying on people who are by nature not trustworthy. If they have vested interest in the outcome of the vote, surely it would be more secure to automate it maybe?
The question is that it would be more secure if we automated the trustees process, and the answer is, well, you need in the end you need a public and private keys, and who is in charge of those keys? You need someone. So if possible, I would do that, but we need someone in charge. So the idea is that we put a lot of people in charge that are not going to collaborate to be corrupt. So time is out, so thank you for coming.
Thank you so